The airframe sits behind glass at the National Museum of the United States Air Force in Dayton, Ohio, and it looks like someone built a jet engine inside an egg. The McDonnell XF-85 Goblin measures 14 feet 10 inches long, wingspan 21 feet 1 inch. It has no landing gear, not reduced landing gear, not retractable skids, none. The machine could not take off from a runway. It could not land on one. Every flight began and ended dangling from a trapeze bolted inside the bomb bay of a Convair B-36, the largest piston-driven bomber ever to enter operational service, a ship so enormous that its bomb bay could swallow a compact fighter whole and still have room for ordnance. The Goblin's entire reason for existing depended on a single mechanical hook catching a single steel bar, while both aircraft hurtled through turbulent air at better than 200 miles per hour. If the hook missed, the pilot had no second option engineered into the airframe. He rode the egg down. So why did the Air Force spend money on this? The answer starts in 1945 and runs through the early thermonuclear math of Strategic Air Command. The B-36 carried 6 Pratt & Whitney R, 4 360 radial engines, later supplemented by 4 General Electric J-47 turbojets in wing pods, and it could haul 86,000 pounds of bombs across an unrefueled combat radius of roughly 3,500 miles. That reach mattered, because in the late 40s, the Soviet Union fielded interceptors, but almost no aerial refueling capability, and SAC's war plan called for one-way deep penetration strikes against Soviet industrial targets. The problem sat in the middle of those 3,500 miles. B-36s cruised at 230 knots. Soviet jet interceptors, early MiG-15 prototypes, and Lavochkin designs topped 450. Escort fighters like the P-81 Mustang or the early F-84 Thunderjet lacked the range to follow the bomber stream past the coast of Norway, let alone into the Urals. The bomber would fly alone for hours through defended airspace. Curtis LeMay, who ran SAC with the subtlety of a brick through a window, wanted a fighter that lived inside the bomber, not alongside it, inside it, carried like ammunition, deployed like ammunition, recovered if the hardware cooperated, expended if it didn't. The specification that went to McDonnell Aircraft in 1945 called for a turbojet-powered interceptor that could fold its wings, retract its fins, fit within the physical envelope of a B-36 bomb bay, and engage enemy fighters at speeds competitive with frontline Soviet designs. If this sounds like the military asked an aircraft company to violate several laws of aerodynamics simultaneously, McDonnell's chief designer Herman Barkey apparently agreed. His first sketches show a man trying to reconcile the volume of a bomb bay with the wing loading of a fighter, and the compromises started immediately. If anyone remembers this strange chapter of Cold War aviation, or has a family connection to the Parasite fighter program, the B-36 crews, or the test pilots at Muroc, hit that comment section below. Stories like these survive because someone decides to tell them. A like and a subscribe keep this channel digging through the records that most people walk right past. Barkey's team threw out the conventional fuselage. A traditional airframe, even a short one, wasted volume on structure that carried no fuel and generated no lift. The Goblin's fuselage curved around its single Westinghouse J-34 turbojet, the way a hand cups a baseball, tight, with almost no wasted space between engine casing and skin. The wing swept back at 37 degrees with a span short enough to clear the bomb bay doors with inches to spare. Triple vertical stabilizers replaced a conventional tail because a single tall fin would have struck the bomber's belly during hookup. Total empty weight came in at 3,740 pounds. The F-86 Sabre, the Air Force's first-line dogfighter in the same period, weighed 10,890 pounds empty. The Goblin carried half a Sabre's fuel in a quarter of its airframe. The engineering bordered on origami. At Wright Field in Dayton, the Air Materiel Command's planning office kept a wall chart through 1947 that tracked every fighter in the American inventory against one variable: combat radius. The longest-legged jet fighter the United States owned, the Republic F-84E Thunderjet, could manage roughly 850 miles on internal fuel. The B-36's target set started at 2,000. That left 1,100 miles of Soviet airspace where the bomber flew naked. The Soviets understood the arithmetic. Soviet air defense doctrine in the late 40s concentrated interceptor regiments not at the borders but deep inland, along the likely approach corridors to the Urals industrial belt, Sverdlovsk, Chelyabinsk, Magnitogorsk. They didn't need to stop the bombers over Norway. They could wait. The escort problem is not a problem of speed or altitude, a 1948 Air Staff study noted. It is a problem of fuel that no external tank configuration currently solves. That phrasing mattered. External tanks added range but destroyed the performance envelope. An F-84 carrying two 230-gallon tip tanks could extend to maybe 1,100 miles, still short, and arrive too heavy and too draggy to fight a MiG-15 on equal terms. Drop the tanks early, and the range vanished. Keep them, and the fighter became a target. The math circled back on itself every time. Aerial refueling could have changed the equation. The British had experimented with probe and drogue systems since 1944, and Boeing's flying boom concept existed on paper by 48. If SAC had pushed tanker development 2 years earlier, the Parasite fighter program might never have left the sketch phase. But LeMay wanted bombers, not tankers, and the budget went where LeMay pointed it. Anyway, McDonnell's proposal solved the fuel problem by eliminating it. The Goblin carried 20 minutes of combat fuel because it didn't need to fly to the fight. The fight came to the bomber, and the bomber brought the Goblin along like a pistol in a holster. 20 minutes of fuel at full military power translated to a combat radius of roughly 0. The fighter operated within visual range of its mothership and returned when the tanks ran dry. The Westinghouse J-34 produced 3,000 pounds of thrust, enough to push the Goblin to 530 miles per hour in level flight. Against a MiG-15 capable of 670, that left a 140-knot deficit. The Goblin needed surprise, not speed. One slashing pass from the bomber's belly, 4 50-caliber machine guns hosing the target, then back to the trapeze before the fuel gauge hit empty. The wind tunnel model that survives in McDonnell's archived photographs looks like a suppository with wings. Barkey's team built it in late 1945 from balsa and sheet aluminum, and the proportions alarmed every aerodynamicist who held it. The chord-to-span ratio on the wing violated established lift calculations for swept planforms. The fuselage contributed almost nothing to overall lift. On paper, the thing shouldn't have flown at all. It should have fallen quickly while making expensive noises. Barkey's solution started with the wing root. He thickened it to 16% chord, roughly double what a conventional swept fighter carried, and buried the main fuel cell inside the root structure itself. The wing became the gas tank. The entire center fuselage, all 38 inches of internal diameter, now belonged to the J-34 engine and its accessories. Intake air entered through a nose scoop with a fixed geometry lip, no variable ramps, no boundary layer bleed. Simple. Every pound of complexity Barkey removed bought him a pound of fuel or a pound of ammunition. "We designed it the way you'd pack a suitcase for a trip you couldn't cancel," Barkey told an interviewer decades later. "Everything had to go. Nothing got its own drawer." The folding mechanism added another layer of difficulty. The Goblin's wingtips hinged upward on spring-loaded joints, so the span shrank from 21 feet 1 inch to a hair under 15 feet, narrow enough to clear the B-36's bomb bay, with 6 inches of margin on each side. 6 inches. The bomb bay doors themselves required modification, fitted with scalloped cutouts to accommodate the Goblin's triple tail fins during the retraction sequence. McDonnell's drawings show 37 separate clearance annotations on the retraction schematic alone. One engineer penciled the word tight next to the left stabilizer gap. The gap measured 4¼ inches. The cockpit sat the pilot in a semi-reclined position, legs elevated, head tilted slightly back. This posture compressed the vertical profile by nearly 8 inches compared to a standard ejection seat arrangement. The Goblin had no ejection seat. Weight penalty, Barkey decided, exceeded the safety benefit at the altitudes and speeds the fighter would operate. If the hookup failed and the fuel ran out, The pilot's exit strategy involved rolling the aircraft inverted and dropping free, then pulling the D-ring on a conventional backpack parachute. From 20,000 feet, that sequence consumed roughly 45 seconds. From 5,000, maybe 12. The armament package fit into the lower nose in a staggered arrangement. 4 Browning M350 caliber machine guns with 300 rounds per gun. Rate of fire ran 1,200 rounds per minute per barrel. Total trigger time before ammunition exhaustion, 15 seconds. Combined with 20 minutes of fuel, the Goblin gave its pilot exactly one chance to do one thing right. McDonnell priced the airframe at approximately $23,000 per copy in 1946 dollars. An F-86 Sabre cost the Air Force roughly $219,000. 10 Goblins for the price of one Sabre, and the Goblins rode free inside bombers already bought and paid for. The cost math seduced the procurement office even when the engineering made test pilots uneasy. By spring of 1948, 2 prototype airframes sat finished in McDonnell's St. Louis plant. The trapeze mechanism, built by Convair in Fort Worth, hung inside a modified B-29, designated the EB-29B, because the sole B-36 available for testing carried a scheduling conflict that the records don't elaborate on. Barkey's team had 14 months of wind tunnel data, 6 inches of clearance, and 15 seconds of trigger time. The clock to first flight started ticking. August 23, 1948, 10:14 a.m., Muroc Army Airfield, California. The EB-29B leveled at 15,000 feet over the desert, and test pilot Edwin Schock sat in the Goblin's cockpit with his knees near his chest, breathing air that smelled like hydraulic fluid and kerosene. The bomb bay doors opened. Mojave sunlight flooded the cavity. Below him, nothing but white alkali flats and heat shimmer for 60 miles in every direction. The trapeze lowered the Goblin into the airstream. Schock felt the buffet hit immediately. The EB-29B's prop wash slamming the tiny airframe in irregular pulses, shaking his helmet against the canopy rail. He pulled the release handle. The hook disengaged. The egg dropped. For 5 seconds, the Goblin fell away from the bomber in a shallow dive, and then the J-34 caught full thrust, and Schock pulled into level flight. The aircraft responded. It actually flew. Lateral control felt crisp. Pitch authority held steady through mild maneuvering. Schock ran the Goblin through a series of gentle turns, rolls, speed changes. Nothing aggressive, nothing beyond 2Gs, for roughly 10 minutes. The handling surprised him. Wind tunnel predictions had called for severe Dutch roll tendencies at low speed. The Goblin tracked straight. Then came the part that mattered. Schock throttled back and slid underneath the EB-29B to attempt the hookup. The bomber's wake turbulence hit the Goblin like a fist. The airframe pitched, yawed, bounced laterally, Schock fighting the stick through oscillations that changed direction faster than he could correct. The hook on the Goblin's dorsal spine needed to catch a retractable bar on the trapeze. The bar measured 6 inches across. Schock's closure rate ran roughly 5 knots. He had fuel for another 8 minutes. First approach, miss. The turbulence threw the Goblin sideways at the last second. Second approach, the hook grazed the bar and skipped off. Third approach, fuel gauge dropping. Schock muscled the stick through a roll oscillation and heard the hook slam home. The trapeze locked. The winch pulled the Goblin up into the bomb bay. The recapture phase, Schock reported afterward, is the most demanding flying task I have performed. The second flight, 3 days later, went worse. Schock missed the trapeze entirely. Turbulence overwhelmed the Goblin's control authority below the bomber, and after 7 attempts, fuel now critical, he belly-landed the Goblin on the dry lake bed at Muroc. The airframe skidded across the hardpan, trailing sparks and dust. Damage, moderate. Pilot, uninjured. Program confidence, shaken. The repaired airframe came back to Muroc in March of 1949 with new belly skid plates and a fresh canopy. The desert smelled like sage and avgas in the early morning, that particular dry chemical sharpness that clung to flight-line concrete. Schock made 3 more hookup attempts across 2 flights. He caught the trapeze once. The other two ended with the Goblin buffeting so violently beneath the bomber that he broke off rather than risk contact between the wingtip and the bomb bay frame. 4¼ inches of clearance, and the turbulence moved the airframe in excursions of 6 to 8 inches laterally. The margins didn't exist anymore. They'd been theoretical to begin with. On the 7th and final attempt, April 8th, the Goblin's canopy struck the trapeze bar during a turbulence-induced pitch-up. The plexiglass cracked from the forward frame aft. Shock, exposed to the slipstream at 210 knots, pulled away and put the Goblin down on the lakebed a second time. He walked away from that one too. Pilot skill cannot compensate for aerodynamic interference of this magnitude, the test report concluded. Their words. The Air Force canceled the XF-85 program on October 24, 1949. Total expenditure, approximately $3.1 million in 1949 money. Total successful hookups across the entire flight test program, 3. Total belly landings, 2. Total flights, 7. Shock never flew the Goblin again. He continued test work at Edwards, Muroc had been renamed by then, on other programs, other airframes, none of them designed to fold into a bomb bay. He didn't talk about the Goblin much in later years. When asked, he called it honest. An honest airplane that flew into a problem no pilot could solve from the cockpit, because the problem lived in the physics between two aircraft occupying the same column of disturbed air. Barkey's team at McDonnell moved on to the F-2H Banshee for the Navy. The parasite concept didn't die with the Goblin. Republic's RF-84 KFICON program carried reconnaissance thunder flashes under B-36s through the mid-50s, but nobody tried a parasite fighter again. The problem we solved didn't need solving, Barkey said in a 1978 interview with the St. Louis Post-Dispatch. Somebody else solved the real problem while we were busy with ours. The somebody else was a Boeing team in Seattle. By 1951, the KC-97 Stratofighter could pass fuel to a fighter through a flying boom at 25,000 feet. A Thunderjet that couldn't escort a bomber past 850 miles could now go anywhere the tanker could meet it. The range problem, the one that justified the entire parasite concept, evaporated. $3.1 million and 4 years of Barkey's career spent answering a question the Air Force stopped asking. But I think the cancellation report misses something. McDonnell emerged from the Goblin program with institutional knowledge that no wind tunnel could replicate, packaging a turbojet into an airframe with zero wasted volume, designing folding structures that survived repeated cycling under flight loads, integrating a weapon system into a fuselage so tight that the gun gas venting required its own aerodynamic analysis, then figuring out the carrier suitability implications of all of it. The Navy noticed. McDonnell's next contract produced the F-3H Demon, a carrier fighter that folded for elevator clearance using hinge geometry refined on the Goblin's wingtips. The contract after that produced the F-4H Phantom. The F-4 Phantom. 5,195 built, 11 countries, 3 decades of frontline service, the defining American fighter of the Cold War, designed by engineers who cut their teeth stuffing a jet engine inside an egg. Declassified in 2003, the Air Materiel Command's final evaluation of the XF-85 contains a passage on page 14 that the summary never mentions. The evaluator, his name is redacted, just a GS-14 civil service grade, wrote that the Goblin's free flight handling qualities exceed expectations for an airframe of this configuration and merit further study independent of the parasite mission. The airframe flew well. The concept around it didn't. The second prototype, ship number 2, serial 460524, sat in outdoor storage at Edwards through the early 50s. Photographs from 1953 show the paint bleached white by sun exposure, the canopy removed, the engine bay open and empty. Sometime before 1957, it transferred to the museum in Dayton. The records don't specify the exact date or who authorized the move. Shock stayed at Edwards until 1954. He flew chase on the X-1A program, the D-558, a half-dozen other test articles. His flight log from that period runs to several hundred entries. After 1954, his name stops appearing in Edwards' documentation. He surfaces briefly in a 1962 McDonnell Company newsletter as a project liaison in St. Louis, working on, of all things, the F-4 Phantom's carrier suitability trials. The same company, the same problem in a sense, making a fighter fit where it shouldn't. After 1962, nothing. 7 flights, 3 hookups, 2 belly landings, 20 minutes of fuel.